We are now going to go to problem number 27. Dee-dee! Now we've done a problem like this, where we took numbers and we plugged them into the X's, and if the answer you get is 0, then that means this is a 0. And if the answer you get is not 0, then that means that the number is not 0. There's an easier way, especially when these get really long. Okay, plugging a number into a really long polynomial can be a total pain. But there's an easier way, and we're going to look at it. An easier and quicker, we were talking about time, an easier and quicker way. So I'm going to move this over to my scratch paper. And we're going to do this. Now I could do that. All right. The question is, are these numbers zeros? Of h of x. Well, there is another method. And here it is. So I'm going to take you through it step by step. The first thing you do is on the left, you make this kind of backwards L. Why? Because that's the way it is. Then, just like back in matrices, only easier, you write down just the numbers, the coefficients. All right, so right here I start 1 and I leave a little space, 2, leave a little space, 2, leave a little space, -6, leave a little space, and 1. Now, I skip a line, and I draw a line, because I'm going to be adding numbers to these numbers right here, and putting the sums, the answers down there. Okay. Now I am going to take the first number here, -2. And we're going to find out if -2 is a 0. Here's how you tell. I'm going to do this method that I'm going to show you called synthetic division. And if my last number is 0, then that means that -2 is a 0. But if it's a number other than 0, that means that -2 is not a 0 of h of x. Then we're going to do the same thing to 1. Here we go. Now watch this. First thing you do is you take this first number, whatever it is, and you bring it straight down and write it here. You're always going to do that. You just bring it straight down. Now, 1 times -2. You multiply this number, whatever it is, by this number, whatever it is. 1 times -2, and then you write it over under the second number there, whatever that times that equals. Then you add the two numbers, which here would technically add them, but really it's the same thing as subtracting. 2 plus -2 is really 2 minus 2, which is 0. Okay. Now I take this number that I just wrote and I multiply it by that number. 0 times -2 is 0. And I write it here. And then I add 2 plus 0 is 2. And then I take this number and I multiply it by the number in the backwards L. 2 times -2 is -4. -6 plus -4 is -10. I just do the same thing again. -10 times -2 is +20. And then I add 1 plus 20, and that doesn't give me 0, it gives me 21. Now let me show you what you've got. We have proven that -2 is not a 0, but what else have you got? There's other stuff here that's actually interesting. Okay, 1, or A, how about that? A, we've proven that -2 is not a 0 of h of x. But what else have we done? Here's what we've done. We have done the same thing as. Now, how did I get x plus 2? X minus -2. Stay with me, or I just want to show you. I have done, by doing this, I have done the exact same thing as if I divided the factor x plus 2 into this polynomial. x to the fourth plus 2x to the third plus 2x squared minus 6x plus 1. And these right here are the quotient I got. That is 1x to the third plus 0x squared plus 2x minus 10. We would call this the quotient. And the remainder is negative 21. So to write this more legibly, A, we've got that negative 2 is not a 0 because the remainder was not 0. B, the quotient that is the answer you get when you divide is x to the third. That's always going to be the coefficient of a number 1 lower in power than what you started with. X to the third. This is your x squared term, but it's got a 0 in front of it. This is x to the third plus 0x squared plus 2x minus 10. So x to the third plus 2x minus 10 is the quotient, and C, the remainder, is 21. And you sometimes write this as x to the third plus 2x minus 10 plus 21 over x minus negative 2, which is x plus 2. You've just done all that. You're pretty smart to be able to do all that. Yes, we're going to do it again. We've got to do it again. We've got to do this whole thing over again with positive 1. Okay, so let me write this, and then I'll scroll up. I'm putting 1 in the backwards L, and then 1, 2, 2, negative 6, 1. 1, 2, 2, negative 6, 1. Yes. So here we go. We are now going to see if 1 is a 0 of x to the fourth, blah, 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 blah. Oops. Here I go again. There. So I'm just going to do this from the beginning, what I did before. Bring the first number, which is not a 7, it's a 1. There, that's better. Bring the 1 directly down, or whatever that number is. Here it's a 1. Multiply 1 times the number in the backwards L, which is 1. So 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. 5 times 1 is 5. Negative 6 plus 5 is negative 1. Negative 1 times positive 1 is negative 1. 1 plus negative 1 is 0, which means this is a 0. 1 is a 0 of h of x. And they're not asking you this, but I'm telling you this. The quotient, that is what you get after you've done your division, the answer to the division, right? Remember, this was 1x to the 4th, so this will be x to the 3rd. All right, x to the 3rd plus 3x squared plus 5x minus 1, and C, the remainder is 0. When the remainder is 0, that means that that number is a 0. So this actually is a lot faster and easier once you've done it a few times. Than plugging a number in and hoping you don't make a mistake and hoping you'll get a 0. And what if you don't? What if you plugged in the wrong number? This is just so much easier and straightforward. So we have just found out by using synthetic division that -2 is not a 0 of h of x, but 1 is a 0 of h of x. Yay for us! And I'm still using the practice exam. Am I recording? No. Or am I? Yes, I am. That little red dot means I'm recording. Yes, yes. Whew, I'm happy. All right, happy camper. Ooh. Now, ooh, this is hard. Who would have assigned this to you? What kind of monster? Me. I had to do this when I was a student, so. We're going to see if 4i is a 0 of this polynomial. Really? Yeah. Okay, I'm going to write it right here. And this is what, number 28. So, up here is number 27. And then down here is number 28 on your practice exam. This. All right, now how on earth are we going to do this? Well, we're going to try to live through it is what we're going to do. I'm going to take 4i. And then I'm going to write down the coefficients. As long as this goes 3, 2, 1, 0, remember that the degree of constant terms is 0. As long as no terms are skipped, all I have to do is write the coefficients. Well, what if they are skipped? Then we put in a placeholder. It's not a problem. Okay, there's my test number, only notice that it's complex. It's not in the real number system. But we're going to do all the same things. I bring this number directly down and write it here. All right, 1 times 4i is 4i. Now this is a real number. -3 is a real number. This is a complex number. Well, right. So the way you write a complex number is you put the real part first, and then you put the imaginary part. And we are now going to take this number and multiply it by that number. I recommend we do it over here. 4i times -3 plus 4i. So that will be -12i plus 16i squared, which is -12i plus 16 times -1. Remember that I squared is always, is always -1.
Professor, where did you get the second 4i?
Right here. I said 1 times 4i is 4i, and then I added it to the number above it. So this is going to be -12i minus 16, but the real part goes first. So this is -16 minus 12i. And now we come over here. This times this is what I've just done. So I'm going to add 4 to -16 minus 12i. And we're going to add these two together. This is a real number. This is a real number. So what I'm going to do is I'm going to add this 4 to the +16. And that will give me -12 minus 12i. So that's what I'm going to write right here. -12 minus 12i. Now, I don't see any way, quite honestly, that we can get a zero remainder, but let us continue on. All right, I'm going to take negative 12 minus 12i and multiply it by 4i. So I'll have 4i times. Yes, okay. 4i times negative 12 minus 12i. Scroll up a little bit. There. While we're doing this, this is going to be negative 48i minus 48i squared, which is negative 48i minus 48 times negative 1. Well, that'll make that positive 48, so this will be 48, that's the real part, minus 48i. Lord, this is getting dirty. Okay, so this times that is 48 minus 48i. And that's going to be 36 minus 48i. This was instructive, wasn't it? This is my remainder. This will be x to the third, x squared, x. Yeah, all right, x to the third plus this x squared, plus this x. Did I lose something? Oh, this is a cubic. Never mind. See, it could have ruined my whole day. And your day. Your whole day. Never mind. Okay. Everything is good. This is a remainder that is not 0. So 4i is not a 0 of this polynomial right here, which is that, g of x. So 4i is not a 0 of g of x. Now there's a reason I wanted to show you this, actually. So many of our theorems deal with real coefficients of polynomials. These are real and rational coefficients of this polynomial. What if they're not real? Here we have a case in point. The quotient are you ready? Is x squared, 1x squared, plus negative 3 plus 4i x plus negative 12 minus 12i. These coefficients are complex. This is what it looks like to have complex coefficients. Unreal coefficients. I just wanted you to see that. And the remainder, yeah, if you were going to write the remainder, it would be 36 minus 48i. So it is possible, and it does happen, that you end up with the coefficients of the x's that are not real or rational numbers. These are not real. They're not in the real number system, they're in the complex number system. Okay. Well, enough of that kind of suffering. Let's go to something else that we didn't talk about last time we were together before spring break. And that is, who cares about the zeros and why are they important? Here's the reason we care. Zeros generate polynomials. They create the polynomials. So here we're told that there are 3 zeros. Find the polynomial that gets generated from them. And it's also clear that they expect us to assume, because we don't know that from the beginning, to assume that, well, you'll see, that the leading coefficient is 1. Doesn't have to be. But okay, so we're going to put these in the polynomial generator. What is the polynomial generator? It's this. F of x, or whatever you want to call your polynomial, sometimes it's called P of x, equals A, the leading coefficient, which we're going to assume right now is 1, times x minus your first c, times x minus your second c, 0, the zeros, times x minus your third 0. Why only 3? Because they say we've only got 3. A degree 4 would have 4 zeros. A degree 5 would have 5 zeros, and so on. Okay, so our zeros are -1, 2, and -8. So f of x is going to equal x minus -1 times x minus 2 times x minus negative 8. Everybody with me? Notice you don't have any unreal numbers here. You are going to have to change the minuses to plus. So we're going to have x plus 1 times x minus 2 times x plus 8. And when you've got a 1 multiplying everything, it becomes invisible. So now we have to multiply our 3 factors together. What I do is I do the last 2 first. Just because over time that has seemed easier to me. It might not seem easier to you. You don't have to do it that way. So I'm going to let x plus 1 wait until I need it. X plus 1. And I'm going to multiply these guys together. X squared plus 8x minus 2x minus 16. So this is going to be x plus 1 times x squared. 8x minus 2x is plus 6x minus 16. Aha. Okay. Now, we're almost done. So hang in there. Take this x, take the first x. And multiply the second set of parentheses, the second parentheses. What's in the second parentheses by it. And then take the plus 1. Bring it over here. Plus 1. And multiply it by this set of parentheses. Oh, plus. There. Now we're going to do that. And that will give us x to the third plus 6x squared minus 16x plus 1 times all of this is x squared plus 6x minus 16. Then combine your like terms, and you'll have x to the third plus 6x squared plus 1x squared is plus 7x squared. Minus 16x plus 6 is minus 10x. Minus 16. And that's what your polynomial equals. And here, what that would mean is what you would fill in right here would just be the coefficient of the x squared. 7. We've generated a polynomial. A cubic polynomial from 3 zeros. There's also an assumption that the multiplicity of each of those is 1. I don't like assuming. Okay, we're going to do the same thing in number 30. Now this was 29. Number 30. This time the zeros are 3, 5i, and its conjugate negative 5i. And we want to generate an f of x. A polynomial. So I use my little generator, and these are like pieces of coal, and I'm going to put them in the generator to make the generator work and pop out a polynomial. So we're going to have a times x minus z1 times x minus z2 times x minus z3. So we'll have f of x equals 1. Remember, a is not always 1. But I'll tell you if it's not going to be. And I don't think you'll encounter, well, I don't know. Let's just get to work. X minus 3 times x minus 5i times x minus negative 5i. So we'll have, there's 1 times x minus 3 times x minus 5i times x plus 5i. And I'm going to do just what I did before. I am going to multiply these two together first. You don't have to, but in this case, it will be easier if you do it. Trust me. X minus 3, because you see these, they're conjugates. We're going to get a very nice answer. X squared plus 5i times x minus 5i times x minus 25i squared. When you multiply linear conjugates like this, your middle terms disappear. Boom, they equal 0. X minus 3, that's not math magic. That's 5i times x minus 5i times x. So notice you're going to have x squared minus 25 times negative 1. So you're going to have x minus 3 times x squared plus 25. Now we're going to multiply these and we will be done. X times x squared is x to the third. X times plus 25 is plus 25x. Minus 3 or negative 3 times x squared is minus 3x squared. And minus 3 times plus 25 is minus 75. The only thing I have to do is put this in descending order because right now we have degree 3, degree 1, degree 2, degree 0. Now that's not the right way. X to the third minus 3x squared plus 25, x minus 75. Oh. So this is our f of x. I guess it's f of x. I don't actually know. Yeah, it's f of x. So let's see, what are they going to want us to do this time? Ooh, they want us to put in all the stuff. So you're going to have to actually end up putting in all the coefficients. Negative 3 plus 25 minus 75. Shh, I already forgot it. All right, negative 3. There's the minus, so 3. There's the plus, 25. And there's the minus, 75. All right, everybody still there?
Yes.
Yes.
Good. Good. You surviving? Tell me yes. Lie to me.
Of course.
Okay, we're going to do a genuinely hard one now. But then they get easier. So hang on through this one. We'll even take a short break. Your reward. Here are our zeros. These are irrational zeros. They're real, okay? They're on the x-axis. Z1 is 2 plus the square root of 3. Z2 is 2 minus the square root of 3. And Z3 is just the number 3. Okay, well. Okay. I don't like that. It makes me feel insecure. So I'm probably going to change them. Not change the numbers, but just change their order. So I'm going to get another piece of paper. There. Insert. We'll put in 5 more. Being optimistic, you can survive. Okay. So here we've got our zeros. I'm going to put 3 first instead of the irrational numbers, just because I want to. Stop it. It's running away too. We're going to be tough, pencil. There. 2 plus the square root of 3, 2 minus the square root of 3. Okay, so 2 plus the square root of 3, 2 minus the square root of 3. So now this will be Z1, this will be Z2, this will be Z3. Have I done anything terrible? No. We're going to generate a polynomial from those and talk about a slightly new method, well, not a new method, but a new concept for multiplying. It's not even really new, but trust me, you may not have done it before. I know you haven't. A times x minus z1 times x minus c2 times x minus c3. So that, we're assuming that's 1, we'll have x minus 3, very benign. Now, bracket, x minus parentheses 2 plus the square root of 3. There are 2 terms there. Z2 is actually 2 terms. Z3 is 2 terms. So I have to start off this way. Now at this point, I remember feeling just absolutely terrified of even attempting anything like this. But I did. And at some point, you just have to have faith that if you go one step at a time, it'll work out. So that's what I did. Minus 2 minus positive the square root of 3 is minus the square root of 3. There, I lived that long. Going to do the same thing over here, just distributing the minus sign. X minus 2 minus minus is plus the square root of 3. And that's what I've got so far. Just to make sure you can see it. Okay, cogitate on that. Now, I am going to perform a superb trick. I'm going to put parentheses around the x minus 2 and parentheses around the square root of 3, just because I want them to kind of stick out like that. Okay, let's see how much room I have over here. All right, now, notice that, well, that's too small. Notice that the x minus 2 and the x minus 2 match. I could call them A. And the square root of 3 and the square root of 3 match. The only difference between these two sets of brackets is that one of them is A minus B, and one of them is A plus B. What would happen if I multiplied A minus B times A plus B? Well, I would get, I'm going to keep the brackets, I don't really have to, but I'm gonna. A squared plus AB minus BA, which is also AB, minus B squared. You following okay? I let x minus 2 equal A, and the square root of 3 equal b, because I noticed that x minus 2 and x minus 2 match, and the square root of 3 and the square root of 3 match. The only difference is that there's a sign in the middle difference, which gave me kind of a minus b and a plus b, and when I multiply them, look how a minus b minus a minus b, a minus b minus, stop it, a times b minus a times b. There you go. They equal 0. I mean, ab minus ab is 0. So all I've got here is a squared minus b squared. Is that cool? That means that if I multiply bracket x minus 2 minus the square root of 3 times brackets x minus 2 plus the square root of 3 together, I will get, yes, x minus 3 is still out there, waiting patiently. I will get this, x minus 2 squared minus the square root of 3 squared. And what that will get me is x minus 2 times x minus 2 minus the square root of 3 squared is 3, because we busted him out of jail. And so I'll have x minus 3 times, I don't think I need brackets now, x squared minus 2x minus 2x plus 4, that's what that is, and then there's a minus 3 on the end, so that I'll have x minus 3 times x squared minus 4x, and 4 minus 3 is 1, so plus 1. Look at that. Look at that. It's not ugly anymore, because these are really conjugates of each other. The middle terms disappear. Leaving me with the first term squared minus the second term squared. It's wonderful. I love conjugates. So now we're going to wrap this suffering up and take a short break. Right, so x to the third minus 4x squared plus x minus 3x squared plus 12x minus 3. So that'll be x to the third minus 4x squared minus 3x squared is minus 7x squared. And x plus 12x is plus 13x minus 3. Dee-dee! Now, let me make this a little smaller. There we are, from the beginning. It works out. It works out. Oh, and look at this. You get to choose. There it is down there. Yep, D. Okay, go take a 5-minute break. Just enough to get up and move around a little bit. And then we're going to wrap this up. My goodness! I thought there was more to this. Yeah, take a break. What's coming up is easy. Doesn't look easy, but it really is. I'm not even going to stop recording. But yeah, I do want to get up and move around a little bit. Here, I will be a role model. You can read my shirt. I guess you can't. I'm disappearing. Help! Help! Oh well. La 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 la. So you think you're going to survive this one? I don't think it's anywhere near as difficult as I thought it was. I think I was thinking of my Monday, Tuesday, Wednesday, Thursday class. Theirs is a little on the difficult side. But you guys, you got it easy. Dog.
Hi, Professor.
Yes.
I have questions on 128.
There it is. Okay.
When we try to find the quotient, why we start to write the x square instead of x to the third?
Ah, yes. I'll tell you. 28. This is, number 28 is x to the third, yes, okay. This is 1x to the third minus 3x squared plus 4x minus 12, right? And then we did our synthetic division, and we got the quotient down here, the quotient and the remainder. It is x squared because once you do your synthetic division, you start at 1 power lower. If this is x to the third, then this is x squared. If that were x to the fourth, then this would be x to the third.
Okay, I got it. Thank you.
You're welcome. Good, good. More questions. I love questions. Kind of scroll back through here. Okay, everybody back? As though somebody would answer if they weren't back yet.
Yes.
Yes.
What we're going to do is going to take 5 more minutes. And then I'll hang out and continue answering questions if you have any, or if not, go to Walmart. Woo! What we're looking at here is, now remember I showed you what it looked like to have complex conjugate, unreal coefficients. It looks like this. Not a pretty sight. Well, it's stipulated here in actually all of these problems up to 35, and then the answers start. So for 32, 33, 34, and 35, you're told either that you have rational coefficients or real coefficients, and since rational numbers are real numbers, let's just say real and rational. All right, so if I can guarantee that the coefficients in a polynomial will look more like this and not like that, then there are going to be some things that have to be true. Now, first, these are 3 zeros. Negative, yeah, why not? -1 and 13/2 are rational. They're real and they're rational. That is, they're rational numbers and they're in the real number system. Real and rational zeros. The square root of 5 is an irrational zero. It's real, but it's irrational. It looks different, right, than those. If I'm going to create, manufacture, generate a polynomial that has real and rational coefficients, then there's something that has to be true. And that is that if I have an irrational zero, it has to be accompanied by its conjugate. That's what they're asking you for here. There's a degree 4 polynomial. And you've got 3 zeros here, Z1, Z2, and Z3. You got to have 4 zeros of some kind. Or they've got to have a multiplicity. Anyway, they have to add up to 4. So what that means is that there's another theorem that says irrational zeros have to be accompanied by their conjugates. Okay, this is the conjugate of that. So the other 0 is going to be negative the square root of 5. And that's all you have to write. The real and the rational numbers don't double up, but the irrationals do. So that's a rule. And these problems are just designed to drill into your head this rule. For instance, now, negative I is a complex 0 right there. This is Z1. It's complex. It's not even real. It's not on the x-axis. It's got its own place. Negative I is complex. And 3 minus the square root of 7, which is Z2, is irrational. It's real, but irrational. However, they stipulate that you're going to have rational coefficients, which means you're going to have real coefficients. So if you're going to have real and rational coefficients, you cannot just have these zeros. They have to be accompanied by their conjugates. So negative I has to be accompanied by I. And 3 minus the square root of 7 has to be accompanied by 3 plus the square root of 7. Negative I and I are conjugates. 3 plus the square root of 7 and 3 minus the square root of 7 are conjugates. So they give you these two zeros. You have to say, aha, you've got a degree 4 polynomial and you're trying to pawn those complex and irrational zeros off on me? Well, I know their mates have to be there with them. So I has to accompany negative I, and 3 plus the square root of 7 has to accompany 7. Has to accompany 3 minus the square root of 7. Same thing is true here. Here we have two again, 4 plus 5i is complex. But they say they want rational, which means real, coefficients. Real and rational. Rationals are real. So you can't have a non-real number without its conjugate if you want to have real coefficients. See, 0. I wanted to write 0 there. Is complex. That's what I wanted to write. So its conjugate is 4 minus 5i. Now, 4 plus the square root of 5 is real, but it's irrational. Let me erase that is. And move it. There. So it has to be accompanied by its conjugate, 4 minus the square root of 5. So these are going to be the other zeros. All you have to do is list them with a comma between them. And now a polynomial function of degree 5. What are we gonna do? Well, here are 3 of the zeros. Negative 1/4 is rational. It's real and it's rational. It's not going to double up or anything. It's okay to stand by itself. But the square root of 11 is real and irrational. So it needs its conjugate. Yeah, its conjugate. And negative 4i isn't real. It's complex. So it needs its complex conjugate, positive 4i. And so you'll have 1, 2, 3, 4, 5 zeros for a degree 5 polynomial. Now it says find the other zeros. The other zeros are negative the square root of 11 and positive 4i. Negative the square root of 11 and positive 4i right here, C. So if a 0 is a rational number, which includes integers and fractions, then it doesn't double up. 1 is enough. But real and irrational numbers, like square roots or pi, or complex numbers, they both need their conjugates if you're going to have rational coefficients. Usually in other books you see real and rational. But that is a redundancy, I admit it. Okay, ladies and gentlemen, we have gone through the entire practice exam. Unbelievable as that is. So I completely throw the floor over to you. To ask anything you want or just say goodbye and go study on your own.
Goodbye. Thank you for today.
Thank you for coming.
Yes, yes, very much.
Thank you. Thank you.
I have a question on number 30.
Sure. There we are.
See. I guess over on your worksheet where you had written the generate out.
Are you there?
Yes.
Okay, good. Okay, and this is number 30, right? Here it is.
Right there. So the second to the last where you have x3 plus 25x minus 3x2 or squared minus 75.
Uh-huh.
Can you remind me how you got that?
Yes, I multiplied, here, let me put a note over here. I split this apart into x times x squared plus 25 and the minus 3 times x squared plus 25. Then I multiplied x times x squared, that's x to the third. X times plus 25 is plus 25x. Minus 3 times x squared is minus 3x squared. And minus 3 times plus 25 is minus 75.
Okay.
And then I put them in order.
Gotcha. Okay. Thank you.
You're welcome. Anything else, just email me or make an appointment if you want to.